Hello everyone. So we're going to go ahead and do solutions here for 3-1. This is the modified version. So I handpicked questions for you guys to do. And again, this is for, of the three, right? Because you get a lesson quiz and then you get additional practice. This is for the first one I always intend you guys to do, which is the Math Excel practice and problem solving, okay? So this one has 19 questions. That's another way for you to identify which part of the assignment I'm talking about. Okay, so this is number 1. Hold on one second. Okay, I want to edit it, sorry. All right. So again, at this point, you've already had the notes from the other video. So at this point, I'm just going to solve these, okay? It's not going to be really long explanations, okay? I'm just going to show you the very gist of how to solve these questions. Okay, so number 1 says, the vertices of triangle ABC are -4, 4, B, -2, 3, C, -3, 2. Triangle ABC is reflected across the y-axis. Okay, so when you're reflecting across the y-axis, this is the y-axis. That means that your shape, whatever shape it is, in this case it's some kind of triangle, that means it's going to move toward the right. Assuming that it's beginning as it shows in all of these pictures with the blue one. Okay. Okay. Let's see. It's reflected across the y-axis and then reflected across the x. Okay. Since in the picture you can tell the blue ones, they all start in the upper left quadrant. Actually, why don't I go ahead and just put in the x-axis. So here's the x-axis down here. So when you reflect the triangle across, it's going to end up somewhere over here, and then when you reflect across the x-axis, it's going to end up somewhere down here. Okay. So let me go ahead and reread that second sentence. Triangle ABC is reflected across the y-axis and then reflected across the x-axis to produce the image ABC, but with double primes. And the reason for that is because we've applied 2 transformations to it. We've reflected it twice. Graph triangle ABC and triangle A prime, A double prime, B double prime, C double prime. Okay, so based on the very inaccurate analysis that I did up here, we can rule out A because that's just way off. Okay, the triangle does not end up in that bottom left quadrant. So it's going to be between B or C. Okay, so let's go ahead and figure out which one it is. So if you look at the coordinates of A, they are -4, 4, which was given to us in the problem. Now, when you reflect across the y-axis, you count how far away is from the y-axis. So it's 1, 2, 3, 4 units. So to reflect it, you have to count the same amount to the other side. So 1, 2, 3, 4. So this is where A ends up after the first transformation. So we're only going to put one little apostrophe. All right. Now, what we're going to do is, instead of reflecting all the points over, meaning like B and C as well, since A's location, A double prime's location in B is over here, but A double prime's location in C is down this way, what we're going to do is we're just going to apply the next transformation to A prime. Okay, so the second transformation is to reflect across the x-axis. So we're just going to ignore B and C and see where A lands. So let's clear this up a little. So at this point, we've landed over here at A prime, and now we're going to reflect across the x-axis. So we're going to count how far A prime is from the x-axis. That's 4 units. And to reflect it over, we got to count the same distance over. So 1, 2, 3, 4. So this is where A double prime lands. Notice that it's not where this one landed. Okay, if you look at the coordinates of A double prime, the coordinates are, let's see, starting from the origin, right? 1, 2, 3, 4, comma 1, 2, 3, 4 down. So the coordinates of A double prime are 4, comma negative 4, which is where this diagram is saying it should land. Okay, so notice that all we did was look at A. We didn't have to look at B and C. So that would be a shorter way of doing it instead of, you know, transforming all of the points of the triangle. Okay, so the answer here is C. All right. This one only has one part. Okay. So it says under transformation, a preimage and its image are both squares with side length 3. Okay, so we're talking about having a square and then transforming it. Okay. And at this point, since all of our transformations don't really change the size and shape of the shape, that's why we can expect for both of them to be squares. So the before and after is still a square. It's not going to change into like a rectangle or something. The image, however, is rotated with respect to the preimage. Is the transformation a rigid motion? Explain. Okay, so a rigid motion is a transformation that preserves size and shape. So it doesn't matter if it's been rotated a little bit, as it says in this question. You can rotate something and it'll still have the same size and shape. It's just oriented in a different way. Okay, so let's see. I'm going to go ahead and start looking at these at the bottom part. So it says a rigid motion is a transformation that preserves either length or angle, or both length and angle measure. So that would be that one. Okay, so it preserves size and shape. So you can think of size as being length, or as corresponding to length, and shape as corresponding to angle measure. Each side in the preimage has length 3, because it was a square with side length 3. And each side in the image has length 3. Again, because it was a square. So the transformation preserves length. Okay, what we mean by preserves, very much what you mean by like, well, if you guys have used the word preservatives for food, it's stuff that makes the food like maintain its integrity, like it stays good for longer. Although people don't really like that there's preservatives in foods nowadays, but it means to like maintain its current condition. Okay, so the transformation preserves the length because the length has remained the same. It's maintained the same length. It hasn't been changed. Each angle in the preimage has a measure of, this is going to be 90 degrees. So this is because hopefully you guys just remember that squares have 90-degree angles in them. And each angle in the image has a measure of 90 degrees as well. So the transformation preserves angle measure. Therefore, the transformation is a rigid motion. Okay. All right, let's go on to number 3. Can a figure be reflected across 3 lines of reflection so the image is the original figure? Explain. Okay. So, let me go ahead and take a picture. If you have a, we can even do it with a equilateral triangle, but that's not the example here in the answer. So let's just do it with the example that is used in the answer. So let's say you have a square. There are lines of reflection that you can use that actually make the square sort of land on top of itself. So for example, if you draw a line right through the middle here, okay, then this point on the bottom right will be reflected over to this side. Notice that it started on top of the square and landed back on top of the square. Also, the point that was there on the bottom left corner in red here that one gets flipped over to the opposite side over here. Okay. And then you can do the same thing with the other two corners. So this vertex here will end up being reflected across the line of reflection this way, landing over here. And then if you think of the one that was there originally, this upper left-hand corner, it gets reflected over to the other side, like this. So all four vertices end up landing back on top of each other. And then if you just go in and reconnect them at the end, which is what we always do when we transform, right? We draw our three images of the three corners of a triangle, for example, and then we just connect them after. Right? So if you just connect these four corners again, notice that you end up with the square being in exactly the same place. Okay, so now this question is asking, are there shapes that have three lines of reflection? Okay, and the answer is yes. So not all shapes have three. Sometimes they have more, sometimes they have less. All of the ones in these options have less than three, except the square, which is what it says in B. Okay, so if you look at B, wait, that's not what I want to do, sorry. So if you look at what B says, yes, it is possible to map a figure onto itself with three reflections if the figure is a regular figure and has symmetry, such as a square. So the line, this red line, that's one line of reflection. I'll mark that with a 1. Another line of reflection can be like this, horizontally. If you reflect the square across that line, then all the points line up also. This time, like, they flip from top to bottom. And you can even do one like this, diagonally. That only works for, well, not only, but it works for the square. So that would be a third line. So here's a second one, here's a third one up here, and it even has 4. So this question didn't go as far as asking about 4, but it could have. It could have said which shape has 4 lines of symmetry. Okay. So the answer is B. An isosceles triangle only has 1. So if you look at B, if you look at option C, an isosceles triangle might look something like this, where this side is the same as this side. There's only 1 line of reflection for this type of triangle. It goes right through the middle like that. So you couldn't do it with 3 lines of reflection. Okay. Tell whether the transformation appears to be an isometry. An isometry is a fancy way for saying a rigid motion. It means that all the lengths stay the same. Okay, and this one does not. The image has shrunk compared to the pre-image. So if we scroll down here, there's a couple of no's. It says no because the angle measures and the distances between the vertices are the same. That's incorrect. Okay, it's true that it's no, but it's for the wrong reason. D has the correct answer. It says no because the angle measures and or the distances between the vertices are not the same. Okay. In this case, the angles are all the same because it's still a rectangle. So it still has the same shape, but it doesn't have the same size. Okay. So that's why they put or in part D, because you only need to violate either or of the conditions so that it's no longer a rigid motion, or in other words, no longer an isometry. Just a fancy word for a rigid motion. Okay, tell whether the transformation appears to be an isometry. This one is no, again, because it has shrunk. So let's look at the no options. B says no because there are no angles or sides in the pre-image or image, so the transformation cannot be an isometry. And C says no because the pre-image and the image do not appear to be congruent. Yes, so C would be the answer here. Okay, so C is the answer. The first one is basically option B is kind of complaining that it doesn't have straight sides or angles. That doesn't really matter. We're not limiting our conversation of rigid motions and things like that to polygons. We can talk about circles and ovals and stuff. We don't normally, but you can. Given points 2, 4, 5, 5, and 3, 2, graph triangle JAR and its reflection image across the given line, the x-axis. Okay. So when you reflect, it should look like a mirror image. Okay. So I think you guys can probably tell that A and B are not mirror images. The points have to travel directly across the line of reflection. So if you look at option A here, J starts up here. Hold on. J starts up here. If it were to be reflected, it has to move in a straight line down across the line. And notice that it completely misses where J lands here. So this graph is not accurate. Neither is B. If you take J's position and you go directly across the line of reflection, it doesn't end up in the right place. That would be like standing in front of a mirror, but your reflection is like not directly in front of you. It's like to the side. That's not how mirrors work. That's not how reflections work. Okay. So C and D look a little more promising. C is the answer here because J actually lines up with J prime, R lines up with R prime, and A lines up with A prime. On this one, the 3 points line up, but not with the right ones. So J lines up with A, which is not correct. That's not where J would land. I'm sorry, that's not where A prime would land. That would be where J lands. Okay, so the answer here is C. I'll say, okay, so it says, given points J 3, 4, A 7, 5, and R 5, 2, graph JAR and its reflection across the given line. All right, so this time the line of reflection you can see is the y-axis given by the little red dashes. And these all look pretty close. So what's going to happen here is we're actually going to have to go in and count and make sure that they're the perfect distances away. So it has to look symmetrical. Okay, so there's a couple here that we can kind of eliminate by looking at them slightly carefully. You don't have to look too hard to notice that they're bad. So if you look at B, right, there's only 2 units apart from from J prime to the line of reflection. But on the other side, there's 3 units. Okay, they're supposed to be equally distant or equidistant from the line of reflection. Okay, so that's not going to work. D shows J is only 3 units away, and then J prime is 1, 2, 3, 4 units away. So that's not going to work. Okay, so we can eliminate B and D. So let's see what the difference is between A and C. It looks like this A reaches the edge of the screen. So let's investigate that, because this one doesn't, but it could just be that, you know, the coordinate plane is not centered. So let's see. A's coordinate is 7. So if you look, A's x coordinate, sorry, right? So if you locate where A is, its coordinates are 7, comma, at a height of 5. That's its location. So that means it's 7 units away from the y-axis. So 1, 2, 3, 4, 5, 6, 7. And if you look at A's distance, A prime, sorry. If you look at A prime's distance, it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this means that this can't be the answer. Okay, because A is too far. So this means that C is the answer. All of the points are equidistant from the line of reflection. Okay, so if you draw line segments from A prime to A, from J to J prime, and from R to R prime, then this bit on the right is, let me use a different color. This little bit on the right is congruent to this one. This tiny one is congruent to this tiny one, and this medium one is congruent to this medium one. Oh, I should put different numbers of little hashes. Remember we talked about this in class, that these little marks tell you the lengths, and if they have the same number, that means that they're equal. If they have different numbers of little marks, then that means that they're different than the other ones. All right, so C is the answer here. Given points 4, 3, 7, 6, 6, 2, graph JAR and its reflection image across the given line. And the given line in this case is x equals -1. Okay, so first of all, you guys have to know where x equals -1 is. So the way you find that line, and it happens to be the same in all of these. So the way you find an equation of a line when it's like x equals something or y equals something, like x equals -1 or y equals, I don't know, 4, for example, we'll graph both of those, is you start at the origin, okay, and then you travel to the point that it says, just along the axis. So in this case, they say x equals -1. So what you're going to do is you're going to go to the coordinate x equals -1, and then what you do is you draw a vertical line. So that's why we have this line of reflection here. This is from algebra, by the way. Okay. But people often forget it. Students often forget it. So let's do the other random example here. So let's say I have y equals 4. What you do is you start at the origin, and then you count to where that says. So it says y equals 4. So you literally go up the y-axis instead this time. 1, 2, 3, 4. Okay. And then you draw a horizontal line instead. And then you'd have to reflect across that line. Okay, so the only difference between this problem and the other ones we've done is that we're reflecting across like a different random line on the screen. We're not reflecting across one of the axes. Okay, but it still works the same. You still have to count how far away the points are from the line of reflection and replicate that distance on the other side. So we can tell A is not the answer because the triangle has been shifted down 1 unit. Okay, so this is not the answer. Also, all of these have the correct line of reflection, so we couldn't eliminate any options by looking at whether the line of reflection was right or wrong. They're all in the right place. Okay, all the other ones are lined up a little bit more accurately, so it means we're gonna have to look a little closer. So let's look at B. Option B, J is 1, 2, 3, 4. J prime, I mean. This is 4 units from the line of reflection. And remember, the line of reflection is the red one now, not the y-axis. And then J is 1, 2, 3, 4, 5 units. So they're not equidistant from the line of reflection. So this couldn't have been the correct reflection. Okay, now we have C and D. Let's just count because it's hard to tell what the difference is. So let's see, this is 1, 2, 3, 4, 5 units. This is 1, 2, 3, 4, 5. So that checks out for now. Let's see. Oh, okay, so that was J, and this is J prime, right? But now notice that this says A, and regardless of how far away it is, but look at the point that it went to, R prime. This doesn't make sense. This would be A's location, so this would be A prime. Okay, and this one says that R. If you did the reflection correctly, you would have to go straight across, and you would get R prime here. But this one is saying that you get A prime, which is not correct. Okay, so they've mixed up where the points land. They got the triangle in the right place, but they got the wrong vertices there. So this one is not the answer, so that leaves D as the answer. All right. So it says the vertices of ABC are -3, 4, -2, 2, -4, 2. A triangle ABC is reflected across the line y equals -1 to produce the image. Find the coordinates of the vertex A prime. Okay, so we only have to worry about A prime in this case. All right, so that's all we're gonna focus on. So let's go ahead and do this one. So the coordinates of A are -3, 4. And it says we're reflecting across the line y equals -1. So we got to be able to find what that line is. So let's draw a coordinate plane. So the way you find it is you start at the origin. And it says y equals -1. So we're going to go down to a value of y equals -1. And then you draw a horizontal line. So it's always counterintuitive. You think of y as being vertical, but when you're graphing the equation of y equals -1, you draw it horizontal. Okay, so we have to reflect the point A across that line. So let's go ahead and find A. So A is -3, 4. So people are struggling, I've noticed, to find just the locations of points. So -3, 4. So starting at the origin, -1, -2, -3, and then up 4. 1, 2, 3, 4. So somewhere around here is A. 3 units left, 4 units up. Okay. Now we have to reflect across the line y equals -1. So when we count, we have to count all the way to that line. So we're at a height of 4 at the moment. 1, 2, 3, 4, 5. So we've gone, it takes 5 units to get to the line of reflection at y equals -1. This means that from there, we have to travel another 5 units down. So if you're starting at a height of -1 and you're going down another 5, this means you're going to end up at a height of -6 down here. So this is where A prime is going to land. Okay, at a height of -6. So let's actually report the coordinates. So the coordinates for A prime are going to be -3, -6. Only the y value changed, right? It used to be a 4, and now it's a -6. The x value doesn't change because the point didn't move to the left or the right. It just moved straight down. Okay, so this is a property of reflections across the axes, across horizontal or vertical lines, which include the axes. Only one of the coordinates change. The other one stays the same. Okay. Suppose line G is the line with the equation y equals x. What are the coordinates of the vertices for A prime, B prime, C prime for the reflection? Okay, so these are some that you just have to memorize. Oh, I notice that this has 3 parts, so I'm gonna have to do this kind of little hack that we do. Not a hack, really. It's a workaround is a better name for this. Okay, so we have 3 parts where it doesn't easily label where the parts start. Okay, so it looks like this top portion here is it's just a reminder of what the properties of a reflection are, this portion. And then I think it starts asking the question here. So it says, first graph ABC show y equals x as the line of reflection. Oh. I mean, the way the question asked it, it just said, what are the coordinates? That's what it says up here. What are the coordinates? So what we're going to do is, let me show you what the rule is for when you reflect across the line y equals x. Okay. So when you're going to do a reflection across a line y equals x, if you have a point with coordinates x comma y, then what happens is it takes it to a point y comma x. So that's fancy just for switching the coordinates. So for example, if you look at the coordinates of A, the coordinates of A are 7 comma, oh, that's a bad example, -7. I mean, it's not a perfectly bad example, but. So the coordinates of A prime, after you reflect across this line y equals x, by the way, this is the line y equals x. Okay, so you could do it visually if you want, but there's a rule that you're supposed to have memorized. All you do is switch the coordinates. So if you take 7 comma -7 and you switch those so that the y comes to the front or to the first spot, you get -7 comma 7. Okay, so let's go plot that, because apparently that is where the reflection would go. All right, so let's go find -7 comma 7. So you start here at the origin. -7 would be 1, 2, 3, 4, 5, 6, 7, and then up 7. 1, 2, 3, 4, 5, 6, 7. So apparently A prime lands over here. Okay. And if you check what they have, you can see that that's exactly what happened. Okay. Now, it looks like they did it by counting, but really there is a rule for reflections across the line y equals x, which is that you flip the coordinates. Okay, so that's something that you want to have memorized. And then what you got to do is you got to do it for the rest of them. So let's look at the coordinates of B. The coordinates of B are 1, 2, 3, 4, 5, 6, comma 1, 2, 3, 4. Oh, I'm sorry. I was going up to the B. 1, 2, 3, 4, 5, 6, 1, 2, 3, right here. So 6 comma 3 are these coordinates. To find the reflection across y equals x, we're going to take 6 comma 3 and we're going to change the coordinates to 3 comma 6. We're switching them. So let's go graph 3 comma 6. 3 comma 6 would be 1, 2, 3, 1, 2, 3, 4, 5, 6 up here. This is where B prime lands. Notice that it is equidistant to the line of reflection. Okay. So this time the points are traveling diagonally, and that's because the line of reflection is diagonal. Okay. They move perpendicular, by the way. So that has gone unmentioned by me, but that is one of the properties of a reflection. If you watch the video with the other teacher, she did say that. Okay. And then you would do the same thing for C. So the coordinates of C are -2, comma 1, 2, 3, 4, 5. -2, -5. A reflection across the y equals x line would be -5, comma -2. So let's go find -5, -2. 1, 2, 3, 4, 5, 1, 2. This would be -5, comma -2. Okay, and if you notice, that does go perpendicularly across, and it's equidistant on both sides. So this is 90, and this is the same distance as this one. Okay, So they do the same thing for those other ones. Delete. And that's it. That's all we had to do, I guess. Oh, wait, here we go. Use the new points to draw a triangle A prime B. Oh, yeah, that's just the final graph. I don't know why it said it had 3 parts. So let's go back and check. So close this. I don't know why it says there's 3 parts. Help me solve this. View an example. Maybe there's a difference. I mean, this is the same thing. It didn't add anything, so. Oh, the 3 parts are the 3 different points. Sorry. Okay, so first they have you put A prime, and then they have you do B prime and C prime. Okay, I thought my little workaround wasn't showing the whole question. Okay. Suppose line H is a line with the equation y equals -2. And then this is A, B, and C. What are the coordinates of the vertices for this? Okay, so this is similar to the one I did like 2 questions ago. Let me find it for you, just so you guys know. What just happened? Did it load up a new problem when I went back? Y equals X, that's the one I just did. This is the one I'm trying to do right now. Oh yeah, it loads up a different problem every time. Let's see, this is 23. This is 24. No, I'm not sure. But we did do a reflection across y equals -1 already. Okay, y equals -2, which is the one that popped up a few seconds ago, or like a minute ago. It would be the same thing, except your line of reflection is even a little bit lower than y equals -1. So you just have to count a little bit further. Okay, so let's see, this one has 2 parts. So let me view an example to load up all of the different parts. All right. So it says, your friend incorrectly says that the reflection triangle EFG to its image E prime, F prime, G prime is a reflection across the x-axis. What is the correct reflection? What is your friend's mistake? Okay, so that's the figure that he drew. So, he's claiming that that's a reflection across the x-axis. Okay, so at first glance, it looks okay, but the problem is that it looks like the line of reflection is here. But that's not the x-axis. The x-axis is this one, which is slightly more bold. This is the line y equals +1. So it looks like a reflection across the line equals +1. So that's his mistake. Why can't I zoom back? Let's see, it says look at the figure and its image carefully. Okay, so here it's just showing what the student put. And then it goes on to the sentence after. The x-coordinates remain the same. Okay, we know that about those reflections. Okay, well, I think we answered both. At the very bottom it says, compare your friend's answer to the correct answer to help find the mistake. Your friend took the reflection across the x-axis instead of the correct line of reflection. Okay, so your friend just said that, the friend says that it's across the x-axis, but it's actually across the y equals 1, the line y equals 1. So let's let's make sure that that's everything that it's asking. So, because it says part 1 of 2, so I just want to make sure. So it says, what is the correct description of the reflection? It is the image of triangle EFG after a reflection across a line. Oh, the question changed. Okay, so this time it's a reflection across a line y equals -1. Sorry, that scared me. Okay, so if you look at this one, the friend is still saying that it's a reflection across the x. But that doesn't work because that would not be the same distance apart. Like the x-axis is not equidistant to all the points. But the line y equals -1 would be. Okay, so let's check the answer in it because it says there's 2 parts. What is your friend's mistake? Okay, yeah, so we answered it correctly the first time. It's just what is the actual reflection and then what is their friend's mistake. Okay. Okay, I'm out of time, so I stopped at 26. I'm gonna have to do a part 2 for 27 and on. Okay.